Hello everyone, myself A. Joseph Descent from Puche Technological University. We as a team going to present our presentation on IoT internship. We a team of 3 members, Kaushik Kumar, Jaikant and myself. This IoT internship was held by Emertex for 4 weeks. First week the topic was basics of C program and C++. In C programming, system software development, embedded software development, OS kernel development, firmware, middleware and driver development, file system development we study. First week is full of deep concepts of C programming which are required for the programming of the embedded concepts in this project implementation. The concepts under C programming. These are the concepts we studied under C programming. They are keywords, data types, conditional operators, operator and modifiers, array concepts, pointers and function, string, memory and storage classes, concept on header file and preprocessor, and finally macros concept. After completing C, we studied C++. In C++, these are the concepts we studied. They are the concepts studied under C++ are main difference between C and C++, structured concepts, access modifiers, constructor and reconstructor. And in week 2 we studied about the introduction to Internet of Things. What is the inflection point of IoT? Hardware is getting cheap, M2M solution are mainstream, connectivity is proliferating. Software is getting more advanced and cloud cost and flexibility. General technique requirement in IoT, many devices, large scale, vague security requirement, volume of data and end-to-end integration. Then challenges. What are the challenges we face in IoT? Addressing, scaling, connectivity, data volume, devices. The principles of the challenges are addressing, pub, sub, scale, cloud, connectivity, queues. For data volume, cloud storage, and for devices, AMQP or MQTT.
Myself Kaushik Kumar, and I will be presenting the IoT architecture. So basically, the IoT means Internet of Things. The architecture involves IP cable devices, which is being given to the client, and the existing IoT devices, that is the Blink app or the other user interface. Low power devices which we use in the system, which we use basically the hardware device or something related to that. And the way which we connect is there will be a cloud gateway, which is nothing but the database which is present in the cloud, where we can access our data. So the data is being given to the solution backend, the processing and analytics, uh, process and analytics things. And the presentation part is the Blink apps user interface, which we see in the Blink. For example, that we did in the home automation project. That is it about the IoT architecture. Embedded system, any combination of hardware and software which are intended to be a specific task, to do a specific task, can be called as embedded system. Components of embedded system: microprocessor and microsystem controllers, system on chip, memories, RAM, ROM, EPROM, flash, NOR and NAND gate, sensor, different types of sensor using for different purpose, actuator for the purpose of converting digital to analog conversions, human interface, the LCD or LED lamps which we use, FGPA or ASIC used for application specific integrated circuits, auxiliary system include power and cooling systems. So the project requirements are Arduino Uno. The Arduino Uno is a microcontroller board based on Atmega 328 datasheet processor. It has 14 digital pin input and output pins. 6 are analog, uses 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a rest button. It contains everything needed to support the microcontroller. Simply connect it to the computer with a USB cable. or power it with AC to DC adapter or battery to get started. Microcontroller Atmega Mega 328, operating voltage is 5 volt. Digital input output pin 14 pins are there. Analog pin 6 pin and the clock speed is 16 megahertz. Output components are LEDs and CLCDs, character liquid crystal display. Simple devices, LEDs are simple devices used in most on the embedded system application as feedback works just like diodes, home lighting, remote control, surveillance, display and many more. Most commonly used to display are ASCII, which is American Character Standard International Code. Some customizations is possible in the symbol. Communication modes are both 8-bit and 4-bit modes.
Functions of LED and CLCD. Pin mode. Pin comma mode. Configure the specific pin to behave either as an input or an output. Digital write. Pin comma value. Write a high or a low value to the digital pin. Digital read pin. Read the value for the specific digital pin, either high or low. Delay ms. Pass the program for the amount of time in a millisecond specific as parameter. There are 1000 milliseconds in a second. For using the LCD function, we have to include the class liquid crystal underscore I2C address comma column comma row. Set cursor column comma row. Set the cursor at the particular position. Print string. Print the string in the CLCD. LCD in it. Initialize the LCD. LCD dot clear. Clear the CLCD screen. LCD dot home. Set the cursor to the first position on the CLCD. LCD dot backlight. Turn on the blacklight. Blink IoT app. Blink is the software required to prototype, develop, and remotely manage a connected electronic device at any scale. For personal IoT projects to the millions of commercial connected products. With Blink, anyone can connect their hardware to the cloud and build a no cloud iOS, Android, and the web application to analyze the real time and historical data coming from the device. Control control them remotely from anywhere in the world, receiving the important notification. In right side, we can see a serial tank. We can see a serial tank which is going to use in the project to control the water tank level, and it's a description of our water tank level project in the simulation model. In the simulation functions of Blink app and the serial tank. Blink underscore write vpin. Blink underscore write is a function called every time a device to get an update of a virtual pin from the server or app. Param dot as int. Param as float. Param as double. Param dot as str. To interrupt the incoming data as integer, float, double, and string uses. Virtual write vpin comma val. Send the data in the various format to the virtual pin. Set the interval time comma functions. Call the function after every particular period of time. Serial dot begin speed comma serial dot begin speed comma configuration. Comma config. Set the data rate in a bit per second for the serial data transmission. Serial dot write value, serial dot write str, serial dot write buf command line. Write the binary data to the serial port. This data is sent as a bytes or a series of bytes. To send the character representation, the digital of a number used in the print function instead. Serial.read. Read the incoming serial data, comma, dot read inheritance for the Steam utility class. For analog input and output, analog write pin comma value. Write analog value PWM waves to the pin can be used to the light LED to vary the brightness or driving a motor at various speeds. Project 1. Controlling the garden lighting. Project segment. This project is about to controlling the garden lighting using the peripheral. The outcome will be the light glowing when the light will glow when the surrounding become dark, and light will stop glow when the surrounding become bright. There is a variation of brightness of the LED with respect to surrounding light. Project requirements. The requirement of the project are LDR, light dependent resistor, for controlling the brightness of the LCD according to the surrounding brightness. Arduino IDE for the program complication. LCD display for output. PIC SimLab for simulation and running the program. Project process. Read the LDR sensor value based on the reading from the LDR. Varies the brightness to the LED, which reassemble controlling the garden light based on the availability of the sunlight. This is a simple architecture of our project one. Project one. LDR sensor is connected to Arduino with the A1 pin, and lights are connected to the Arduino using GPIO3 pin. As we can see now, there is LED is not glowing because of high brightness around the surrounding. In this second diagram, we can see second output. We can see that LED is glowing due to the low brightness around the surrounding.
Now we will see our second project, that is temperature control system. Project statement. The temperature control system consists of a heating resistor, an LM35 temperature sensor and a cooler, which resembles the temperature control system at home. Read the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature of the system by turning on or off the heater and cooler through the Blink IoT mobile app. Project requirement. Requirement for the project are temperature system for using the cooler, heater and temperature sensor, Ethernet shield for connection between Pixie Lab and Blink application. Blink application for controlling the temperature system in the mobile phone. Threshold temperature control. Process. Read and compare the temperature with 85 degrees Celsius. Output. If the temperature is more than 35, turn off the heater and send notification to the Blink IoT app and display the same on the CLCD. Outcome of this project. Temperature control system. Process. Read temperature from temperature sensor LM35. Output. The output will be display temperature on gauge widget, display temperature on CLCD. Second one, cooler control system. Process. Detect the change in the logic level. Output. If the button widget is at logic high and turn on the cooler. The button widget is logic low, turn off the cooler. Heater control system. Process. Detect the change in the logic level. Output. If the button widget is at logic high, turn on the heater. If the button widget is at logic low, turn off the heater. Architecture of connection. These are the connection made for this project. It comprises of 4 components, namely Blink IoT app, Arduino Uno, CLCD and temperature system. Blink IoT app is used to control the heater and cooler, and also we can see the notification in Blink IoT app. The CLCD also provides notification output and it will display the temperature, and Arduino provides the temperature control and display it on CLCD. These are the screenshot of our project, where you can see the values on the CLCD display and we can control using the Blink IoT app.
So moving on to the project 3, water tank inlet and outlet valve control. Project statement: read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Display the volume of the water in the tank on the CLCD. Project statement: project requirement. The requirement for the project are remote serial tank for displaying the inlet and outlet, null emulator for COM communication, the PixSim Lab and serial tank, Ethernet shield for connecting the Blink IoT app, and the Blink app for controlling the inlet and outlet while using mobile phone. Display the volume of the water in the tank. Process: read the volume of the water in the tank by sending commands through serial communication. Output: display the volume of the water on the gauge widget, which we have created in the Blink app, and display the volume on the CLCD. Outcomes: inlet valve control. Process: detect the change in the logic level. Output: if the button widget is at the logic high, turn on the inlet valve by sending commands through serial link communication. If the button widget is at logic low, turn off the inlet valve by sending commands through serial communication. Outlet valve control. Process: detect the change in the logic level. If the widget is at logic high, turn on the outlet valve by sending commands through serial communication. If the button widget is at logic low, turn off the outlet valve by sending commands through the serial communication. Control the volume of the water in the tank. Process: read the volume of the water in the tank by sending commands through serial communication. Output: if the volume of the water in the tank is less than 2000 liters, turn on the inlet valve and send notification. If the volume of the water reaches 300 liters, 3000 liters, turn off the inlet valve and send the notification and display the same data on the CLCD. So the architecture goes like this. Blink IoT app. We are connecting the V3 virtual pin which we have created in the data stream of the Blink app to the volume of the water, inlet valve V5, outlet valve V6, and notification, that is a string which we are sending through the Blink app. And again through the CLCD we are sending the notification and volume of the water. Water tank volume of the water is been updated. Inlet valve and outlet valve control is been there. The water tank uses COM7 and Arduino uses COM6 processor. So CLCD board updates regularly the water tank, the volume of the water. The inlet valve which sends the data, that is the 2000 liter data to the Arduino, and the Arduino sends through the the Arduino sends it to the Blink app, and we can control through the Blink app using the virtual pins V4 and V5. So V4, the volume of the water, which is the gauge that shows the level of the water, and accordingly we can control the inlet valve, inlet valve pin, which is V5. And using, when the condition satisfies above 3000 liters, we can control it through the outlet valve control, that is 3000 liters, that is V6. So it is the screenshot which we have taken when doing the project. The screenshot goes like I2C display and the serial remote tank. The Blink app shows when the temperature is above 35 degrees Celsius, turning off the heater, water level is full, water inflow disabled, water level is less than 2000, water inflow enabled. So water inflow disabled. First, when the water level reaches 2000 liters, the inflow is enabled. Water level reaches less than 2000, the outflow level is enabled. So the same thing is done for outflow here. The guard shows the app.
Now we will see our project demonstration.
First, we will see the garden lighting control here. The brightness of the surrounding is very low, that the surrounding is dark, so the LED glows bright. If we increase the brightness of the surrounding, the LED brightness will be reduced. If it's a daytime, the LED will not glow.
Now we will see our second project demonstration, that is temperature control system. Now we will open our Blink app from mobile phone and we click on the on switch from the cooler. You can see it start rotating and it shows on LCD display. And if we turn off the cooler, it stops rotating. And now the heater is turned on. We can see the temperature increases, and after reaching 85 degree it stops and show notification in the mobile app.
Then we will see the demonstration of the 3 project, which is nothing but the serial tank, the control, water level, inlet level control. Here we can see the TC is for home 7. In Pixel it's COM6. Here first I'm going to on the outlet valve. The water level is decreasing, that is shown here in the CLCD and the Richard gauge also. Here the notification has came like water level is less than 2000, water inflow is enabled, and here also we can see the inflow is on. Then I stop outlet, it shows outlet outflow is off. Then the water level is increasing because inflow is on. Then if you stage 3000, the full capacity of the tank, it shows the notification like water level is full, the water inflow is disabled. If I turn on the outlet, it is decreasing. If it comes under 2000, the inlet, its water level is inflow and water is enabled. We can see the simultaneous in CLCD also. This is a home automation blink control code. The allied files are there: serial park, temperature, CPP, temperature, system H, and etc. So thanks note, it was a very great experience learning the basics of C, embedded system, and Internet of Things, and the communication between the Blink app and the Arduino board. The internship was designed in a more structured and user-friendly way to learn the domain in deep. We as a team had learned a lot of things in terms of building and implementing the project. The internship has provided us a confidence in building a new project and implementing by ourselves. We thank the mentor of all the sections who has put in their time to make us understand the concepts and gain an hands-on experience in our core field. The resources provided by the mentor helps us go through the internship in a more comfortable manner. The experience which we had gained through this internship will act as a basement for our career. We thank Emertex Technologies for providing us this great experience. Thank you so much. And we as a team acknowledge Emertex Technologies and the CEO, Mr. Jaikumar sir, for providing us this great opportunity. Thank you so much.